record to this.
Yeah, you're
Yep,
recording
we're
now.
good.
Okay,
Okay.
so shall we begin?
Yeah, please.
Okay, good. So, as usual, same day, same time. We are at week number 14 of life after code in place 2025, and I'm happy to still see 15 people in attendance. So that's that's good. I think we reached a plateau. So we have more or less the same amount of like real geeks staying until the very end. So I'm happy to have you here. And as usual, we have 3 seconds of organizational notes. Hey, Leah, hello.
Whoa.
And so we're going to look at this, and this is very exciting. And here is, as usual, a reminder of office hours by both Emma and Dieter. So don't forget to visit them if you have any questions pertaining to the contents of this course. And today in week 14, we actually have a number of topics that we will try to cover. At the moment, I cannot promise that we will cover all of them, but I will try. So the topics are tuples, sorting, Lambda functions, and list comprehensions. And then the next 3 weeks will be devoted to search, doing the bajillion engine. And the last 2 weeks are object-oriented programming. At least we'll start discussing this. So that's for the schedule, but as usual, first, before we go into the content, we have a quiz. The quiz is, as usual, there will be actually several images from the same location on the next screen, and what you would have to try to do is name the location, the country where it's located, and the name of a Oscar-winning movie that had an iconic fight scene filmed in this location. So the first person to type in these three things will, as usual, win something from Vicky. As far as I understand, we're still in CIP t-shirt territory. Please
If
correct
you
me if I'm
want
wrong.
one. I mean, if you
If you
don't
want
want
one.
one, it's fine. I mean, I'm still willing to give them away because there's only a couple weeks left.
All right.
And the stock
So
market is strong.
let's take a look at the images. So here are the three images that we're talking about. So once again, you need the location, the country, and the movie. Go, go, go.
30 seconds.
I know the movie, but I do not know the location and the country.
You actually know the movie?
Yes,
Oh,
I thought I told you that. I told you that this is well, for me, it was the second
you don't
easiest
see
one
an
because
image? Steve doesn't see an image.
what
I see it.
does, no, I think that's something with Steve.
We see
Well, I
three
mean,
images.
Ah,
yes. So anyone. Well, okay, there we have the name of the movie. So, but then you need to know the location, the name of the location, and the country. And that I do not know.
or you could just do what Nick does. Is uh uses Gemini AI.
I would also guess, I see Alyssa wrote China. That would be my first guess, although I'm
Okay.
I'm not sure
All
that's
right.
actually the correct
I
one.
think 30
Okay,
seconds is
we
up.
have an answer from Sandy. Sandy is saying Japan, Arashiyama bamboo forest.
That is,
AI used.
I mean, Nick came the closest, but even this time, I'm guessing he probably used AI.
I don't
AI
see,
was
I don't actually see an answer
right.
from Nick.
I told Nick to like privately message me.
Okay, okay, okay,
But even AI could not identify the right location. He got the country in the movie correct though.
okay.
So,
Will you enlighten us?
oh, do you have do you have that video I sent you?
No, I'm sorry. I just thought that watching 4 minutes of video, not
I
with the
didn't tell
topics
you to
that we
watch
need.
4 minutes. I just said to show 15 seconds. Okay.
Okay, no, I
Well,
don't have it.
okay. So anyways, the movie is Crouching Tiger, Hidden Dragon, movie by Ang Lee that won the Oscar for Best Foreign Film. The country is China, and the location is the Anji Bamboo Forest, which is about like 30-40 minutes outside of Westlake. And so really nice place. If you get to visit this beautiful, gorgeous country sometime, I hope you'll get to appreciate the sublime beauty of China and everything it has to offer. So I promise next week's will be easier because I'm hoping before the end of Life After Code in Place, I can give away another free t-shirt. So.
And if you haven't seen the movie, please do. It's worth at least one watch.
Although I do not understand the ending of that movie, so
You know, Asian movies can understand the endings. Okay, so the plan for today is to actually break up our session into 3 parts. Well, hopefully we get to do all three. I mean, this might be a bit optimistic, but first we'll talk about tuples and sorting. I hope, we'll finish in 20 minutes, and then we'll do assignment discussion for those 2 topics in the main room. So we're not going to do rooms today because that would take up too much time going back and forth. So we'll do it together here. And then the next topic we're going to discuss is Lambda functions, and we'll do a couple of assignments on that. And if we have time, we'll talk about list comprehensions and go through some assignments as well that were actually not from the second part of CX 106, but actually were created by one of the SLs from the previous year. So the first thing we're gonna talk about is tuples or tuples. I still don't know how to pronounce this because it's not a real word. I have no idea why these things are called tuples or tuples because there is no other thing in the world which is called like this. Anyway.
Yes, there is. People talk about it's a generalization of the idea of a double, a triple, a quadruple, a quintuple, something like that.
Okay, so it's like double, triple, quadruple, and tuple.
Yeah.
I think that's just some people came out with this idea because I actually looked for the etymology of this word and I couldn't find anything. But maybe.
That's what I was led to understand by David Galertner's book.
Okay, so quite possible. So I still don't understand what it has to do with a quintuple, etc. But okay, let it be that. It's not that important in the end. So tuples are an ordered, immutable data structure. But an easier way to explain this is to say that tuples are basically lists that once created cannot be modified. So you can modify elements in a list, you cannot modify elements in a tuple. And that's basically the difference. So whatever you can do with lists, you can do the same things with tuples except for actions that actually modify the contents of a tuple. So anything that's used to modify a list cannot be used in a tuple, but anything that can be done with a list that does not modify it can be applied to a tuple as well. And many people ask the obvious question, why would you have tuples? Because obviously tuples are less flexible than lists. Why don't you just use lists? And the reason for that is that tuples operate more efficiently than lists in terms of memory management, in terms of speed sometimes. So whenever you actually want a sequence of elements that you know will not be modified during your program, you can use a tuple instead of a list, and you can feel yourself that you're doing the smart thing because your program is going to run slightly faster than if it were a list. So that's the basic introduction to tuples. And creating a tuple is fairly easy. It's very simple to create. It's very similar to creating a list, with the only difference that instead of square brackets, you use the usual round, parentheses. And here you can see I am creating a tuple called names, which has four values in it, separated by commas. This can be any type of data. It can be strings, it can be integers, floating point numbers, or other data structures. You can have a tuple of lists, a tuple of tuples, a tuple of dictionaries, what have you. One thing that's important to note, if you want for some reason to create a tuple with a single value, you have to do it like this. You have to write this single value and then place a comma after it. Because if you do not place the comma and you're just doing 42 inside parentheses, that will actually be an integer and not a tuple, because any integer inside the parentheses is that integer without the parentheses, much like in math. So if you want to specify that it's a tuple, you have to include sort of this trailing comma for one value, because this will not be a tuple. This will be just integer 42. Some of the common tuple functions and methods, much like with lists, you can use the len function to get the length of a tuple. You can access elements of a tuple using indices. So in this case, the index 2 is clear. You can use the index method to find the index of a certain value. For instance, in this case, Bob is at index 1. And you want to count the number of instances of a certain value, much like in a list. So for instance, 22.7, you see it's twice in this tuple, so that would give you 2. However, you cannot modify anything in a tuple using indices. So saying names index 2 equals, for instance, Cindy, will provide a type error, because a tuple is not a type that you can modify like that. Also, if you try to use any methods which modify a tuple, be it append, pop, remove, or anything else to that effect, you will get an attribute error. So Python will say that it does not have this. It does not simply have this method, so you cannot use it. And this is a question. I see a good question in chat. Why would I ever need a single value tuple? Is it not better to use the value itself? Good question, but often you will, for instance, read values from a file into a tuple because you wouldn't know in advance how many values the file will have. And you could run into a situation when you have only one value or you have 0 values. So you cannot use the value itself, because later in the program you will need to work with a tuple, because in every other case you would have a tuple. So this is a simple situation where you would need a single value tuple. But obviously it will not be created like this here. Obviously it will be created in a different manner. But yeah, this is the answer to your question. And Vicky, I also saw your raised hand. Did you want to add something or ask something?
Yeah, so I have a question. If
Sure.
you actually have a nested tuple, like say where the elements of a tuple is something mutable,
Yes.
like a
List, like a tuple
yeah,
of
list,
lists.
okay. And so even though the tuple is an immutable structure, If you have
Mhm.
elements that are mutable structure, can you change those elements or would that still give you an error?
This is a very good question, so thank you for asking it. The answer is yes. You would be able to change the contents of those elements. So, meaning that you would be able to change the elements of the lists, which are themselves the tuple. And the reason for this is that remember, lists are actually pointers to locations in memory. So when you're changing something, you're not actually changing the memory location which is saved in the tuple. It remains the same. You're changing something at that location, but no change occurs to the tuple itself. So that's why you can do this. That's why it's possible.
Okay. Your pointer comment lost me again, but that's okay. We can take it offline. Everything else up until that point was pretty clear.
The pointer, I mean, I think we discussed pointers and references so many times, but you
Yes,
still.
but I keep on forgetting. It just doesn't stick. So,
Okay, so without the explanation, the answer to your question is yes. You can change mutable element by the tuple, even though the tuple itself is immutable.
can you provide an example?
An example. Okay, so let's say, let me even maybe,
Um, maybe you could just type it into the chat and
that's what
then,
no, I'm not going to type it into the chat. I'm going to type it actually into VS Code. So let me show it here. So let's say, for instance, we have some tuple which is called, I don't know, cities, and it's going to be a tuple of lists. Let me do like 3 lists, and I'm gonna have some American cities like New York, Seattle, San Francisco, Francisco, and then the second one I'll have some Russian cities like Moscow, I don't know, Tver, Kazan, and then the third one will be some European cities like Paris, Rome, and I don't know, London. And now, let's take a look at things that I can do and that I can't do. So I cannot do something like this. I cannot tell Python to change the list of cities here. So I can't say, get rid of New York, Seattle, and San Francisco, and add like Sao Paulo, and I don't know, Brasilia. This will produce an error. So if I run this, it will say tuple object does not support item assignment. So I will comment this out and say this will produce type error. However, I can actually change the list itself. So what I could do is say cities 0.append and add some fourth city. I don't know why it's Portland, but for some reason it's Portland. And then we will, if we print out cities, we will see that there is no error and Portland is actually added as a fourth city to the first list in the tuple. So I hope this is a good example of how
Yep.
what works and what doesn't work.
Yep. Thank you.
Okay, cool, 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 cool. Let me quickly look. Okay, so back to the slide. If there are any more questions or comments on tuples, please let me know because basically this is what there is to discuss when it comes to tuples. I don't think there is a reason to go deeper into it because these are the basics, a very type, but you need to know about it because it is used. So you have to be aware of its existence even if you don't decide to use it yourself. Shoot.
Um, One other comment, for these immutable data types, they can be used as keys for dictionaries, but the mutable data types cannot. And
That is true.
And that relates to something called whether it's hashable or not, which I can't explain. But if you want to know more about why like immutable data types are hashable, you should go to like Dieter's and Nick's office hours, because they can explain it better.
All right. So, shall we then tackle the second topic, which is sorting? Let's start, and if you still do have any questions on tuples, so basically, let me know. Sorting. First of all, it might seem obvious, but let's talk about what sorting actually is. And sorting is the process of arranging or rearranging the elements of a sequence in a certain order. So it's ordering elements. But the interesting thing is that actually ordering elements is not as simple as it may sound, because obviously we all think, okay, we know what ordering is from smallest to largest, for instance. But then you go, how do you order strings? And you say, okay, that's easy. You go from A to Z. But then you go, but how do you order lists? And it kind of gets tricky. So there are actually many different ways of ordering stuff. And we'll talk about this today. So first of all, this is something that's already been covered in CIP, so we're remembering it, sort of covering it again, how to sort a list in place with the sort method. And when I say in place, this means that you do not get a new list which is sorted. You actually take the old list, you rearrange the values in the old list, and now it becomes ordered. So you lose access to the unordered state of the list which was there initially. And the way this works, for instance, let's say we have a list of integers, which we call numbers, which is all mixed up. And then if we apply the sort method to it, the list will be sorted in place. And note that it doesn't return anything. So the method does not give you back a new list. It simply changes it in memory and does not give anything new. So in Python, it returns the none value. And this is important because if you were to write something like numbers equals numbers dot sort, you would actually get, instead of a sorted list, you would get this value none, and you would go scratching your head like, where did my list go? It did not go. Well, you basically trashed it and replaced it with this none value. So you do not have to assign the result of the sort method to a variable. And if we print this, we'll actually get the sorted list from -37 to 123 in ascending order. So by default, sorts by in ascending order. A second way that you can sort in Python is by using the sorted function. And here you might ask, like, what's the reason for having like two different functions to do the same thing? But they don't do the same thing. So once again, sort is only a method that can be used for lists. It's a list method. It cannot be applied to any other data type. You cannot apply it to a tuple. You cannot apply it to a dictionary. You cannot apply it to a set. You cannot apply it to a frozen set, whatever, all the other data types. But the sorted function can be used with any sequence that you might have. It actually sorts it. What it does, it actually turns that sequence into a list, then sorts that list, and then returns, this is important, it returns the newly created list. So unlike the method sort, which does not return anything, this one does return something. So let's say, for instance, we have two sequences. The first sequence is a tuple of 5 integers. We store that into numbers. The second one is a variable called word, which is simply the string Python. And remember that a string is also a sequence of characters. So now let's use the sorted function on both of them. In both cases, we will get a sorted list of elements, and I will actually store it into two new variables, result1 and result2. And if we print result1, can someone tell me what will actually be printed on the screen? What will be the result of using sorted on the tuple of numbers? Any idea? Okay, so Mansi is writing, yes, we will have, it would actually be a list. So square brackets are necessary. It would be a list starting with -3, then a 1, then the 0, then the 2, then the 15. But otherwise, you are correct. It will be a sorted list. What do you think will happen if we sort the word Python? What would you get as the result?
Wait, Alex, why would 0 come after 1?
No, 0 will come before 1.
Okay,
I
okay,
might have misspoken, so.
okay.
So any idea what will happen if we sort the string Python?
Sort the string.
A string is a sequence. It's a sequence of characters.
Oh,
So you can iterate over a string using for, you can sort a string using sorted. But okay, so Mansi's idea is also correct because it's a sequence of characters and we're turning it into a sorted list. It will be a list of characters. So the result would be the first one will look like this and the second will look like this. But the only thing that you have to bear in mind that Python still sorts them arithmetically. Any idea, can someone tell me, do you have a guess why the capital P is going to be at the beginning of the list?
because of that ASCII code thingy.
Yes, exactly. This is because of the ASCII value. Remember that in the ASCII table, capital letters have a lower ASCII number than the small letters. So they go, I don't remember the exact ones, like from 60 or 70 something, I think from 65 or something. And the small letters go from 90 something. I don't remember the exact numbers. But the thing is that the capital P will have a smaller value, so that's why it will be sorted arithmetically to the beginning of the list. And then all the other letters obviously will go in alphabetical order. So I hope this makes sense, because these are two ways that you can, depending on what you're sorting. Now, why would you always want to, sort in ascending order? Sometimes you need to sort in descending order, starting from the highest values and going down, down, down. And in this case, you can do that using the reverse named parameter. You can do this both with the sort method and the sorted function. This is what it looks like. Let's take the same list of numbers. What you need to add is the named parameter reverse, and you need to set it to true, because by default it's false. If you don't mention it, it's false. If you set it to true, you will see that the list will be sorted from highest to lowest and not the other way around. The same applies to the sorted function. If you add a parameter reverse equals true, the letters in your list will be sorted in descending order, starting from the highest ASCII value and ending with the lowest ASCII value. So a very simple way of reversing the sorting. But often you want to sort something according to some entirely different criteria, because at the moment the only sorting that we're doing is actually arithmetic or mathematical sorting. With the letters, with numbers, it's still the same. It's mathematics. I see a question: does the sort function work with other data structures too, other than the list? There is no sort function. Sort, like I was saying, is the method which is exclusively a list method. So if you want to do sorting, to sort something other than the list, you would have to use the sorted function, and you will get a list sorted list as a result. So yeah, no problem. So let's say that we actually do not care for the, mathematical part of what we're sorting. For instance, let's say we have a list of names and we actually want to sort according to the length of those names. So we want to start with the shortest name, then longer, and at the end we want to have the longest one. So in our case, we have Bob and Dan at 3, we have Andy at 4, and we have Claire at 6 symbols. How do we do that? With basic sort or sorted, we can't do that. But both these function, whatever you call them, allow you to specify a sorting key. So the key that you use to sort the values. For instance, you can use a very specific function to sort by length. In our case, that's the len function, because that's how you learn what the length is. The way this works is the following. Python checks each element, passes that element through the function that you're sending in as a parameter. That function returns a value, and Python sorts according to these returned values. It's still, in the end, it still sorts numerically, it still sorts mathematically, but it sorts according to the number that's actually returned by the function, which you specified as the key. So in our case, Andy will be sorted as a 4, Bob will be sorted as a 3, Claire will be sorted as a 6, and Dan will also be sorted as a 3. So that's the reason why it's going to be Bob, Dan, Andy, and Claire. And the reason Bob is first and Dan is second is because Bob comes first in the original list and Dan comes second in the original list. So this order is preserved. I think that's the reason. This is actually something that I would check, because now I'm thinking maybe it would sort by the first letter, but I don't think so. But we'll check that to make sure.
Yeah, it'll preserve the order in the original list.
The original order. Okay, so that's what I thought. Thanks for clarifying. For instance, another example, let's say the same list of integers and we want to sort them by their absolute value. So we don't care whether it's negative or positive, we want it to be ranked according to the absolute value. And there is a function which does that. There is a function abs, which returns the absolute value of an integer or what have you. And we can pass this function as a parameter as well, and it will give us the following result. Note that minus 37 is between 13 and 42. So it doesn't make sense mathematically, but it does make sense once you remove the minus. Then it sort of becomes obvious why it's here and not somewhere else. And the important thing that you need to pay attention to is when you are passing a function as a parameter, you need to exclude the parentheses. So note here that I don't have any parentheses after lang, I don't have any parentheses after abs. The reason for that is that I do not want to invoke the function in this location. I actually want to pass the name of the function. I'm saying here is the function that you need to use when you're going to be comparing, but I do not want the function to actually run in this specific location in the code. So that's why there are no parentheses. If you do include the parentheses, you will get in some cases strange unexplained behavior, and in some cases you would get errors. So pay attention to this thing. Let me take a look at the... You're saying I hear a baby babbling in the background. Is that Junior? No, I have another baby. Of course that's Junior. Who else? That's him. That's the guy. Anyway, the interesting thing about sorting with using functions is that you can actually do that with user-defined functions. So you can actually write a function for your specific criteria by which you want to sort, and then pass that function as a key and the sort method or the sorted function will perform that, sorting according to your wishes. Let's say, for instance, that I want to sort a list of strings not by the first letter of a string, but by the last letter of a string. So I would create a function which is called very intuitively get last letter, and it will return whatever's at the -1 index of the string. So it will take the last character of the string and return it to you as a result. So I hope it's clear what this function does. Now what you could do, once again, we have Andy, Bob, Claire, and Dan, and we sort them, and for the key parameter, we pass the name of this function. Get last letter, once again, pay attention, no parentheses. And now it sorts, so it takes each string, it passes into this function, it gets a value as the result, and then it sorts by that value. So in our case, it gets Y from Andy, it gets B from Bob, E from Claire, and from Dan. And those are the values according to which the original values are sorted. So in our case, you would have Bob first because it's a B, Claire second because it's an E, Dan third with an N, and Andy last, obviously, with a Y. And you can come up with, tons of different ways of sorting your lists. Your fantasy is the only limitation, what functions you want to write. And this is like the first place I think we need to take a break and actually do a couple of assignments, because otherwise, if I continue talking about theory, you're just going to phase out. I already see Vicky yawning because, come on, Alex, how much can you talk? We need to actually do something. So let's talk about a couple of
just
from assignment. No problem. So let's take a look at a couple of assignments which were in the reader for today. So the first one is called pi difference problem or pi difference assignment. And what I would propose for us to do is to implement a function which is called get pi difference, which takes in a number n. It could be an integer, it could be a floating point number, doesn't matter. And it should return the absolute value of the difference between, pi, in our case, pi is going to be 3.14, and the given number. So it doesn't matter whether the number is higher than pi or lower than pi. We're only interested in how far away from pi it is. So that's what it means by absolute value. And then we would need to list of numbers by using this difference as the key. So using the sort method. So this is the first assignment, and we're going to do this together. So first we need to, let me comment this out. First we need to define the function. It's going to be our user-defined function, get pi difference. It takes n as a parameter. So
Alex, we cannot see your terminal.
Okay,
Just
yeah,
a
thank you.
slide.
Yeah. Let me thank you for shouting out. How about now?
Great.
Yes.
Okay, super. So get pi difference is the name of our function. How do we write this function? How do we return the absolute difference between a number and pi? Can someone help me out here?
You could use Lambda, but
Oh,
you
come
could
on,
just
smarty pants.
You
You
could
just need to show off.
no, because I was trying to practice Lambda because I never understood it. You
We'll
could
get to
take
Lambda.
your input, subtract, I think 3.14,
Yeah.
and then I think there is a function called absolute function. It's like ABS or something like that.
Yes, we just discussed it. And then what do we do with this?
You would assign it to a variable, or you could just return it.
Yeah,
I
just
think we can just
return
return it. Yeah, there we go. So that's basically the function which gives us the absolute difference of n as compared to pi. So now let's say we have a list of numbers. I think I actually have one. Let me take it from the presentation. Can I take it from? Just give me a second. Okay, so here is a list of numbers. It's an unsorted list, and we want to sort it by difference from pi. So can someone tell me what the code for that would be? How do I sort it according to this difference?
We can use sorted, sorted with, I think it was parentheses, numbers, comma, key equals get pi difference.
So numbers, comma, key equals get pi difference, like this.
Yeah, though, as I already made this mistake once, if we want to be able to print it, I think we have to assign this to a variable.
Okay, so
So I don't know, new list or answer,
okay, let's go with answer, yes.
and then print the answer.
And the answer. So what you're doing here, you're actually creating a new list. So you're preserving the original list. So for instance, this could be necessary for your program. You're creating a new list. You are using the sorted function, you're creating this new list, which is sorted according to the function we just defined, and you're printing out the results. So let's see whether that's what it does. Here it does. So this one is obviously 0, 0, 5 difference. This one is like 0, 4 difference. This one is like 0, 55 or whatever. So it does seem to sort in ascending order of difference. How would I change this if I wanted a descending order? So if I wanted to go from largest to smaller difference.
Add in
Reverse
inside
is equal to true.
Yeah, exactly.
Yeah, so this is a second parameter I could add here, reverse equals true. And if I launch this, we will see that now it's done the other way around. So basically we used a bit of reverse, we used a bit of key. We're now masters of sorting using a user-defined function. So let's take a look at another assignment. Let me bring back my screen. And the second assignment was called case insensitive assignment. So we have a list of strings and we want to sort it by the first letter, but we want to make sure that the case of the letter doesn't matter. So whether it's a capital letter or a small letter, it would still be in the correct alphabetical order. So for instance, let's say we have a list of 4 names. We have capitalized Bob, we had all lowercase Andrew, we have capitalized Carol, and we have all, lowercase Charlie. So the question is, what do we use as the key in this code? Because the logic is the same. We need some function will help us ignore whether the letter is capital or not, and provide the following answer. So first we have a lowercase Andrew, then capitalized Bob, lowercase Charlie, and capitalized Carol, all in alphabetic order. And let me, I'm just looking at the chat right now. Leah, I only now saw your question. Could one import the math library and use the value of pi? Yes, of course. Obviously, you could do that if you were serious to find, the very specific difference. In our case, I took 3.14 just to make sure that we don't go into details, but absolutely. Okay, so I see, Vicky, your answer. We could use, we know that we have the lower method, which is a string method that returns the lowercase version of any string. So all the letters in that string are going to be lowercase. But then you could think, okay, so if we need to pass that as a key, let me get back to VS Code. 1 second. It would be enough to write something like, let me copy that list. So we have this code. I just need to put in normal quotes instead of this weird crap I have. Think that for the key we would need just lower, but that doesn't work because there is no function which is called lower. There is only a method which is a string method. So in order for Python to understand that we're actually referencing a string method here and not some function, we actually need to write, as Vicky correctly wrote in the chat, you need to first write the data type, then period, and then the method which is a part of the definition of the data type. So in our case, we would need to write str.lower. And then, in this case, you would get the necessary result. As you can see, we have lowercase Andrew, capitalized Bob, lowercase Charlie, and capitalized Carol. So the value by which the list is sorted is the ASCII code of the lowercase first letter. As a scientist, I shudder at defining as pi equals 3.14. I can understand. I can remember 5. I remember that it's 3.14159. Anything beyond that, my memory doesn't serve me well. But obviously, in this specific case, I'm not doing it for mathematical clarity. I'm just doing it as an example, but I can certainly feel your pain. And yeah, I like Nick saying 3 is a better approximation than 3.14. We can go to 0. 0 is the best approximation of pi. So we can do the same for uppercase, obviously, and it would give us the same result. There would be no difference whether we're using lower or upper, because obviously comparing lowercase letters to each other provides the same result as comparing uppercase letters to each other. They're different ASCII codes, but those letters compared to each other have higher or lower ASCII codes the same way, whether it's lower or higher. Okay, so I think we're good with the first part, which was sorting. We didn't really do anything with tuples. We'll come back to tuples a bit later. But now, unless there are any questions on this or comments or anything, do shout out. Otherwise, I'm going to go back to the presentation and we'll talk about Lambda functions. Okay, so Lambda functions is for me, I remember it was a somewhat hard topic because if you look at the formal explanation of what a Lambda function is, it does not, explain anything. I was still looking at it and going, but why would I need that? That sounds so bizarre to do this, because basically a Lambda function is a one-line anonymous function which is defined using the Lambda keyword instead of the def keyword, and you look at this and you go, and so what? Why do I need this? And obviously we'll look at this in examples building on the previous sorting examples. So the Lambda syntax is the following. It's written in one line. You have the keyword Lambda, then you have one or more comma separated parameters, then colon, and after the colon, you have some sort of expression. And the way it works is that the lambda function takes in these parameters. These parameters are used in the expression to calculate something, and the result of that calculation is immediately returned in line here. So instead of this lambda parameters expression, you actually have the result of calculating the expression using the parameters provided. So basically, you are creating a one-time function, so you're not saving that function to memory. In this line, you're creating a function. This function performs an action, and then it's discarded. And you're saying, this function anymore, I just needed to create it once to use in this specific location, and then I'm done. I don't need it anymore. And it's a lot easier to look at this from an example point of view, because like Vicky was saying, we could have actually done the sorting in the previous assignment using lambda function, and this is exactly what we're going to do right now. Look at the example. We had 4 names, and instead of writing, remember the previous one, we defined a function which was called get last letter, which returned string -1, but that's a rather useless function to define and put into memory. What we could actually do is for this specific sort, we could use a lambda function. So it begins the same way. It says key equals. So after key equals, we need to pass a function. And previously, we just passed the name of the function that we want to use separately defined. But here, instead of that, we use the lambda keyword, and the function definition and execution actually takes place here. So this is the only place where the function exists. After that, it's gone. It's deleted from memory. So we're saying lambda, our function has only one parameter. You can call it whatever you want. I'm calling it string because that's actually what is passed as a parameter here. So Andy is a string, Bob is a string, Claire is a string, Dan is a string. I could have called it name because these are also names. I could have said lambda name. Then I have the colon, which signifies that the expression is going to follow. And, oh, sorry, this is actually, I think this is a mistake. There shouldn't be a return here. Let me quickly fix that because that's on me. It doesn't need a return. Sorry. I was doing it in a somewhat shaky mental state. So basically, after the colon, you specify what your function will return, and in our case it will return the last character of the string. Or if we wrote lambda name, we would have written here name square brackets -1, and this will give you the same result. It will give you the list sorted by the last letter of of each string. But now you do not need to define the function separately, and you need only one line to perform this sort. And once again, I am sorry for having the return keyword here. It's not supposed to be here. And I would guess that something in the chat is probably to the same effect. This is what happens when you don't proofread your slide, but since I was actually finalizing the slides today, I decided not to bother you because you always scream at me that I'm sending them too late, and I'm very nervous about it, and I'm scared of you, and yeah. So you're asking, can you call it X? You can call it whatever you want. You can use X because X is very short. You just say lambda X colon X -1. That would have the same effect. The reason I'm using string or name because it's more, it has more meaning. It carries more meaning. And yes, I see Nick also wrote that people use short names simply because lambdas are supposed to be short one-liners. And the reason some people ask, why is it called a lambda? That was one of the first questions I had in my mind. why is this called lambda? So lambda is a Greek letter which means L, and there is no immediate connection in my head why. And in reality, it comes from mathematics, because lambda is used to signify anonymous functions as well. And the reason why in mathematics it's called a lambda function is not very clear to me. And I don't think anyone knows for sure why the person who came up with that in the 30s, so about 100 years ago, actually used the lambda letter for this. So Vicky, I see you're asking, what if you want to type an entire function with conditionals using lambda? All lambda functions have to be in a single expression. So you cannot have more than one expression or one statement in a lambda function. But you can use tertiary or ternary, what's the word? I forgot the word, ternary operators. So remember, ternary operator is an operator which allows you to use both if and else, and that would still be considered one expression. So you can use that for a conditional, and it can be a number of conditionals, because you can say, if, else, if, else, if, else. You cannot use elif, so elif is not supported by ternary operators, but you can use, a long string of if, else, if, So it's doable, but at a certain point in time, it gets very difficult to read, and maybe not the best usage of a lambda function. Maybe it's better to define that function then. Nancy, the one that you wrote, that's not the one which is used in Python. I think this one comes from C and C++. In Python, it looks like this. It looks like, I'm going to write it in the chat, expression if condition else expression. So this is what it looks like, the ternary operator in Python, but the logic is the same.
Can you show a ternary operator? Is like,
Sorry?
can you give an example of how would you write a lambda using like a ternary operator?
Yes, let's do that once we go back into VS Code, which is going to be right about now. Just let me finish up with the chat. So I got it to work assigning a name to the lambda function rather than key directly. Lambda. Yeah, you could do this. So Martha, you sort of created the lambda function, but then saved it into a variable, which defeats the point of doing a lambda function, because the idea behind lambda functions is that they are not saved into memory. So
you
basically,
just toss it in
yes,
the one place you need it,
and then you throw it away. Exactly. So then it simply stops being a lambda function. It becomes not anonymous, and if it's not anonymous, it has a name, then it's not a lambda function by definition. So you can do it, yeah, but then can you do a loop in a lambda function? As far as I know, no, you cannot do a loop in a lambda function, although I've been proven wrong in the past, so maybe I don't know something, some weird syntax. But as far as I know, you could probably use a comprehension which employs a very loop-like structure, but it's not the same, it's different. So let's take a look at another couple of assignments. So the first one was called zip code tuple sort. So now we're going to work with the tuple as well as sorting, and we're going to do it a lambda. So that's a sort of prerequisite for this assignment. So we will have a list of tuples. Each tuple will contain a city, a country, and a zip code. And we need to sort by the numeric value of the zip code. using a lambda function. So for example, let's say we have 3 locations. We have Moscow, Russia, and this is my actual old index in Moscow. The second one is Yerevan, Armenia, 0012, that's my current zip code. And we have Stanford, USA with Stanford's zip code. So we have three tuples. And we need to sort this by the value of the zip code in ascending order. So we get Yerevan first, Stanford second, and Moscow third. So the question is, what kind of lambda would we write here? Any takers? The fear factor is mutual. Okay, that's funny.
Like X bracket 2.
So you would say lambda x, and then the expression will index 2. Or you could do x
Yeah.
minus 1, which would give you the same result.
Yeah.
Yes, because then your lambda function would return the last element of each tuple, and in our case, the last element is the index. And that's the value by which the tuple would be sorted. And not the tuple, sorry, the list of tuples would be sorted.
So
So yes,
can I just ask you to clarify something about the syntax of lambda, right?
of course.
So when you're using lambda, you need to write out lambda, and then you need to have like a name or a variable, right?
Yes,
And then the colon, whatever comes after the colon is your expression or operation you want to be done,
yes, yes. This
right?
is very similar to a standard function definition. So instead of def, you have the word lambda. It serves the same purpose. Then you have the parameters. The difference is that you don't use the parentheses that were used in a regular definition. You just list the parameters separated by a comma. Then, much like in a regular definition, you place a colon. And the difference is that when you use def, the body of the function is on the next line and it's indented. In this case, it's the same line. Since there's only one line, there can only be one expression. It's on the same line. But the logic is very similar.
And in terms of what can be a parameter for a lambda, okay, basically any data structure can be a parameter, including even like a list or a dictionary or a nested structure. I mean, I don't know why you would want to put a nested structure into a lambda because I mean, I don't know,
You
but in
could.
theory, it could be a parameter for a lambda, right?
Yes, yes, there are no limitations to what you can pass as a parameter to the lambda.
Okay.
Much like with a regular function, same thing in this case. So, any questions, comments on this specific exercise where we sort a list of tuples by the index? Because there is another one that we're going to look at. This one is called sorting with lambdas. And once again, we're going to use lambda functions. We once again are going to have a list of tuples. And this list of tuples is going to contain 3 things. It's going to contain the address of a house. It's going to be a street. Then it's going to contain the number of bedrooms in a house. And it's going to contain the price of the house, like the price of renting this house. And there are different criteria by which we want to sort this. So we'll have 3 of them. The first one, we want to sort by ascending order of the number of rooms. So first the house with the least rooms, then second, then third. The second one be descending order of price. So first the most expensive, then middle, then least expensive. Carlos, we can hear you talking. Could you please mute your microphone? Thank you.
I'm sorry.
No problem. And the third one, we want to sort in ascending order by price per room. So here it's a more interesting thing because we need to manage both, like how do we get price per room? Well, we obviously need to know the price, the total price, the number of rooms, and use them both in order to get the criteria by which we're going to sort. So once again, here is the specific code. For instance, we have 3 houses: Main Street, Elm Street, Pine Street. First one has 4 rooms, second one has 1 room, third one has 2 rooms, and you can see the prices: 4,000, 1,200, 1,600. We want to sort each of them, like we want to sort this list 3 times, and each time we need a different lambda. So the question becomes, if we want to sort by this ascending sort by the number of rooms and get Elm, Pine, Main, because Elm has 1, Pine has 2, Main has 4. How do we perform this one? Okay, so I see different ideas. Yes, so Vicky, second try is good. Because here we need to sort by the first index. The first index is the number of rooms. So sorted by that, we would get this result. So if we want to sort descending by price, how do we do that? Oh, Vicky, you are hurrying again. We need to add one thing which is not present initially. We would obviously use
Reverse.
the second index, but we also need to use reverse equals true. So Mansi, the only thing you need to pay attention to is that true has to be capitalized, because in other programming languages, true is lowercase, but in Python it's always capitalized. Otherwise, Python would think that it's a variable name. And the third one, let's talk about the third one. Can someone else throw in their idea of how would we sort by ascending price per room? Oh, okay, I see Vicky's answer. So basically the idea is that we pass in once again X, and the way we do this, we need to take the total price, we need to divide it by the number of rooms. So we take the second index, we divide it by the first index, and the resulting price per room is going to be the criteria by which we're going to sort. So this is the correct answer. So Martha, I see you're saying you did the same, but added parentheses around the staff after the colon. In this case, it doesn't matter because anything after the colon, there is only one mathematical operation. So there is actually no, you don't need the parentheses because
It does the whole thing.
Exactly. There is nothing to order in terms of arithmetics operation. The only thing I'm thinking right now, could that lead to something strange happening, like it returning a tuple? But I don't think so, no. It would not return a tuple. It would work just as advertised. So there is no, this is not incorrect. This would give you the correct result. It's just unnecessary.
Got it.
Okay, so good stuff. I think we sort of went by these assignments very quickly. So it's obvious that at least those of you, participating and answering, it's obvious that you did your homework. But however, I can't, vouch for those of you who are just listening but not participating. So once again, if there are any questions, something you don't understand, something that you need, please let me know now so that we can deal with it. I would be more than happy to answer any questions that you have, because the way it works is that usually Vicky is the one asking the questions, but she doesn't ask all the questions because some things she knows already, so she doesn't ask. So anything
Oh no, I just go to like Dieter's office hours and then I bombard those people with
There you go. There you go.
because whatever I don't understand here and I know like takes a long time, I just like go to their office hours because like he and Nick, this is also an advertisement that you should come and hang out with them because they know a lot.
Exactly.
You don't know how much
Exactly.
trouble we've saved you, Alex. You don't know what your life would be like otherwise.
Oh, that's true.
True. Actually, true. True. Thank you very much. Thank you very much. I do appreciate it.
And
I
at
do
this
appreciate
point,
it.
sorry. And at this point, I'm just a tourist. Thank you very much.
Yeah,
Well,
soon I'll
Nick, that's
become
just
a
your
tourist.
opinion. You know, like Dieter hasn't said anything. I mean, maybe that's just like how you feel.
Okay.
I'll ask him next time before you show up.
I'm a nice person.
Uh, okay,
That's
so
supposed to be.
uh, we
Yeah,
actually,
I did struggle a little bit between using sorted versus the list dot sort. Um,
okay,
but we
but did
figured out
you,
we figured out that I was I used sorted, but I didn't assign it to anything. I didn't assign it to
yes.
a variable, and
Hmm.
so I it kept not giving me anything, and I couldn't figure out why. So it's just one of those obvious in hindsight problems. But yeah, I just kept forgetting that it didn't actually. It's like having a function that went off and did something. It didn't return anything.
Right. And it's actually, you're correct about saying it's very logical in hindsight. And this is why, for me, sometimes it's difficult. You sort of think, okay, this is like obvious. But what I do usually is I remember like 10 years ago how hard it was for me. So I remember having the same questions like, why do I have two different functions which perform the same thing? But then you sort of they don't perform the same thing. They actually have different reasons for their existence and they work differently. And once you get into it and you understand why they behave differently, it sort of clicks into place. So it's perfectly normal to go into this. Why isn't my function doing what I'm expecting it to do? You just need to go through the explanation and then it sort of clicks. So
Yeah.
now, do I understand that now you are sort of more or less?
Yeah. And what the biggest thing I've learned today is like the Lambda, just pop it right into the function where you're planning
Yeah,
on using it. I do
yeah.
have a question about the assignment wanted us to use the Python terminal for the exercises, or at least it was encouraging use of the Python terminal. Um,
Okay.
I found that very difficult because, I'm still experimenting and trying to figure out what I'm doing wrong, and I need to be able to go back and change things and adjust it. So I still created separate files for it, but when would you want to just use the Python terminal for something? Because obviously they were trying to encourage the use of it, but I don't
Right.
know why.
It's a good question, and it's a question that, thank you for asking it. There is an answer to it because sometimes I do use the terminal, and I usually do it to check some things because I do not remember everything. I mean, it's impossible to remember everything in Python. So I always double check myself in cases when I'm not sure. And the reason to do that, you just open the terminal, you type in a command, you see the result, and you sort of go, okay, that's the way it's supposed to work. Or you go, oh my God, I forgot about this. It actually works differently. So whenever you want to check something very quickly, a terminal is a very quick way to do it because it loads up very fast. Like for instance, if you compare it with PyCharm, you need to open a project. You need, first you need to wait for PyCharm to load and then takes like 10 seconds. And then you need to open the window to create a project. You create projects, you create files for that project. All of this to write one line of code, you sort of go, And even VS Code is slower than just opening, the Python terminal, typing in one line and making sure that it works the way it's supposed to work. So I hope that answers your question.
Yeah, thank you. Because I was like, I don't think I'm ever going to hold enough of the program in my brain to type it in line by line into the
Hmm.
terminal and without having to go back and correct something. So, um, okay, good. I
Okay,
don't have to know it that far in advance.
so I see Nick is saying that he has a permanent terminal open like all of the time. I suppose you have a Mac.
Yeah.
You just don't turn it off, so that's the way Macs
Yep.
work.
Exactly.
Exactly, because I'm on Windows, so I turn off my computer each time, I finish working and then turn it back
Yeah.
off
I
again.
used to do that.
So yeah. So I'm the kind of guy who closes all the tabs before, going out. So I always have a clean browser. So we're different in this sense, Nick. You and I, we're very different. But it's good practice. If you always have it, you can actually use it as a calculator. That's true. And I think it's actually faster than using the built-in calculator where you have to, press buttons with your mouse. You can just, type it in and get the answer. Team Clean Browser. There we go. That's the team I'm on. OCD man. That's me. That's me. So we actually have 40 minutes more. We're more or less close to the timeline that I initially envisioned, which is a pleasant surprise. So we can actually talk about list comprehensions. And I know that Vicky wanted to hear this stuff. And I remember that
Oh,
at
it's
some point you
okay. I
said,
went to office hours on Wednesday and like Dieter and Nick explained it really well. And so I think like I understand it now.
okay, that's good. Good stuff. Good work, Dieter. Good work, Nick. Now, Vicky is not even asking me questions. So
I know,
I'm
see?
that's nice. I think I'm gonna cry. So let's talk about list comprehensions. This is like a very weird pair of words together. The first time I heard list comprehension, I went like, what's that even supposed to mean? And I still do not have an answer to that. Why is it list comprehension? I think my English is failing me in this specific instance. The word comprehension to me is like meaning. You comprehend something, you understand something. So obviously here it's used in a different sense. But list comprehensions, what they are a very concise way, a short way of generating lists in one line of code. So much like a lambda is a way to create a function, a simple function in one line of code, a list comprehension is a way to generate a list in one line of code. And sometimes that's very helpful. List comprehensions are an example of something which is called syntactic sugar. And I know Vicky is always laughing at this syntactic sugar and just going, I don't understand what syntactic sugar is. It's not something you put in tea, that's for sure. Lambdas, I would say lambdas are also syntactic sugar because you can live without them and you can live without list comprehensions. So if you don't know lambda and you don't know list comprehensions, you can still, write programs. That doesn't limit you as a programmer. The reason why they're called syntactic sugar is because they actually do not provide any computational advantages. So they don't make your code work better. Moreover, I actually think that list comprehensions make your code work a very, like, little but worse than if you were to use, a simple list. I think we actually did tests on that. And the time for a simple list was a bit faster than for a comprehension. Just give me a second. I'm looking at the chat. How do you type multiple lines on the Python console? You just press enter and enter the next line. Or if you need like with an indent, then that's what Snake is saying. It will see a colon, and after a colon, it knows that you need to write something with an indent. So yes, you need to press enter twice. List comprehensions are faster to write though, because instead of 3 or 4 lines of code, you only need to write 1 line of code, and I will show this in an example. And many programmers think that they actually look cool. So if you write a list comprehension, you're sort of on next level. You understand higher level stuff. And the rookie programmers, like beginner programmers who do not understand list comprehensions, you sort of look at them and say like, little ones, my padavans, you will soon learn, what the force is about. But list comprehensions can sometimes be over abused. If you use too many list comprehensions, especially in more complex code, this could lead to making your code difficult to read. And I know some people enjoy this. They enjoy writing obtuse, unreadable code that performs a certain task, but in reality, it's not very good practice. Code should be readable by other people, and code should be readable by yourself 6 months from now. So let's look at the specific example. Let's say we need to create a list the usual way, without list comprehensions. We want a list of numbers, for instance, from 1 to 10. We need to create such a list. So initially, we will create an empty list. Then we will do a for loop, using range as the sequence, range from 1 to 11, which gives us numbers from 1 to 10. And inside this loop, we'll write numbers.append, for instance, number multiplied by 10. So if we run this code, what will the list look like? What will be the end result if we print this? What's going to be the contents of this list?
Gonna be it's gonna be like 10 to 100, right?
Yes, it's going to be a list of integers from 10 to 100 because each integer from the sequence is multiplied by 10 and added to the list. So as you can see here, we needed 3 lines of code to create this list. But there is a way using list comprehensions which will do the same task in 1 line of code. And I have my cat walking past. And the way to do it, creating the same list using list comprehension, here is the syntax. Same thing. So let's take a look at it. First, you will notice that we have the square brackets. And these are the same square brackets that we have here. So in the usual way, we just had an empty list. And here the idea is the same. You have numbers equals square brackets. So this is the way you show that this is actually a list comprehension, because you could also have dictionary comprehensions, you could have set comprehensions. So in this case, we have a list comprehension. Now, inside these brackets, you have code which is very similar but more succinct than the one we have in the first example. So here you have 3 parts. The first part is an expression. So in our case, the expression is number multiplied by 10. And it's the same expression that we have in the 3rd line of code here. After that, we sort of have something looking like a for loop. We have for number in range 1, 11. And it's the same thing that we have here in the 2nd line. We have for number in range 1, 11. So basically the syntax is expression for iteration variable in some sort of sequence. The only difference is that now, instead of writing this in 3 lines, you can squeeze it into 1 line and it will give you the same result. And this reads, place the variable number multiplied by 10 into the next location in the list for each number in this sequence, which is a sequence of numbers from 1 to 10. So it's absolutely the same in terms of the result it's going to give. It's just more concise. It's a very short way of doing it. Another example, let's say we have a list of names written, capitalized, lowercase, uppercase, snake case, and let's say we want to create a list of these names all in uppercase. So we want all 4 to be in uppercase. The usual way would be to create an empty list, to iterate over the list, and to append each name, apply the upper method to it and append it to the newly created list. If we print this, sorry, instead it should be names, if we print names, we would get a list of 4 names, all in capital letters. So the question is, can we do the same with the list comprehensions? And the answer, as you would probably guess, is a very resounding yes. So the way we do it with the list comprehension is like this. We say upper underscore names equals. So once again, we have the square brackets on the outside. And inside the expression is going to be name.upper for each name in the list names. So here we also iterate over each name. We apply the upper method to each of those names that we iterate over, and then it gets added to the next location, to the next index in the list until the loop is done. So the result will be the same. Yes, Vicky.
Yeah, so I have a comment and a question. So one thing that I just realized 2 days ago, and I was very excited by this, is that when you have these comprehensions, whether it's a list comprehension, whether it's a dictionary comprehension, okay, there is always a loop involved. Okay. I failed to realize this, which I think it's why I got the list comprehension and Lambda confused a lot because they're both like shorthands. But when you do like a list comprehension, okay, you need a loop and you're just basically looping over list. Okay. If that helps, people to try to understand it because for a year I didn't realize that. And then the other thing, which, Nick and Dieter was really helpful to help me understand, is I was confusing the two because I feel like their syntax is a little bit different. Because when you have a lambda, okay, the parameter part comes first, and then your expression comes later. But when you have this like list comprehension thing, okay, um, it's like your expression comes first, and then your for loop comes later. Okay. And so if that comment helps anybody to understand it, you can take it or leave it, for whatever it's worth. But it helped me. My other question is for list comprehensions, okay, because you're also writing it in one line. Can you use like a ternary conditional in your for loop?
Yes, and this is something which we're going to discuss basically on one of the next slides. But the
Okay.
answer
Okay, I'll
is
wait.
yes. You can use ternary operators in any expression. So basically, the answer is yes. Leah, I'm seeing you're saying, I see we drop list methods in list comprehensions like append. This is actually, you're saying in plural, you're saying list methods, but that's actually the only method that we're dropping by using list comprehension. So a list comprehension by default appends each following value of the currently existing list as it's iterated over. So your comment is spot on. We do get rid of the append method, but that's the only thing that list comprehensions sort of shorten for us. They get rid of the necessity to write dot append. I hope that clears up your question. It doesn't do
Yeah,
this to any other
thank you.
methods. No problem. No problem.
So just to clarify, list comprehensions are used in only to append to drop the append method in this case. In general.
They're used to create a list from scratch. So before you do a list comprehension, the list does not exist. For instance, you cannot modify a list using a list comprehension. So it's always creating a new list. While using append, you can append to an existing list. But here, the append is used inside only.
Got it. Thank you, Alex.
No problem.
In other words, okay, you're not changing the existing list in place. You
No.
are applying a function to like every element of this list and then generating a new list.
Yes. And it's important that you can iterate over anything iterable. It doesn't have to be a list. You can iterate over a range function, you can iterate over a string, you
That's
can
not
iterate
technically
over a
true though.
tuple. Why?
Because, we did have this conversation offline. And then I actually asked you, whether you could do like a tuple comprehension.
Tuple.
And then
No, no,
you
that's a
said,
different thing. I'm saying you can iterate over anything. The result will always be a list. The list in list comprehension comes from the result that you, not what you're iterating over.
oh, huh, okay. Because you could have dictionary comprehension as well.
Yes,
And then I
yes.
thought it's a dictionary comprehension because you're iterating over a dictionary.
No,
Um,
you're actually getting a dictionary as a result.
oh, okay. Okay. And so you could iterate over a list and then turning the result into a dictionary, and that would be a dictionary comprehension instead of a list comprehension.
A dictionary comprehension is a comprehension that iterates over any sequence, but the result is a dictionary.
Okay. Okay. Got it.
Yeah. So, Mansi, you're saying names equal for name will be wrong. It will not be wrong. This will work as well. The difference is that you will get rid of the old list. So you'll basically switch the variable names will now be pointing at the new list. It will be storing the new list and you will lose the old list. In the case that we have here, we retain the old list, which is, the original, and then we have an updated different list which has all the uppercase strings. So the difference is only whether you want to, get rid of the old list or you, for some reason, you want to keep it. So it's not going to be a mistake. It's not going to generate an error. Okay, so unless there are any other questions or comments, or shout out as soon as you have them, going back to what Vicky was asking, list comprehensions can also employ the if operator to create lists which are based on a condition. So once again, if we look at how we created lists previously, we could have used conditions to decide whether a value goes or doesn't go into a list. And we can do this in list comprehensions as well. However, it's important to note that list comprehensions cannot employ the elif or the else operator, so it can only employ the if operator. However, and this is, Vicky, what you were asking, the expression which is a part of the list comprehension, so what you have in the left part, that part can use the ternary operator, which employs both if and else. This is probably a mouthful to read and listen to, so it's better to look at this as usual in an example. So first, let's say we want to create a list of positive numbers based on this list of numbers that we have. So in the past, we would have created an empty list, let's call it positive. Then we would iterate over the list of numbers, say for number in numbers. Then we would write a condition, say if number is higher than 0, and then we would write positive dot append number. So the end result here would be a list of positive numbers, 1, 4, 34, 48, the 4 that are positive. However, we can do the same thing using a list comprehension, and this is what it would look like. You would say inside your square brackets, you would say number for number if number is higher than 0. So once again, you have expression. In our case, it's a very simple expression. It just repeats the variable. It says, like, append the number for each number in the list of numbers, and then in addition, it says if that variable is higher than 0. And what this does, if this condition is false, the value is just skipped. If this condition is true, then the value is appended to the end of the list during the list comprehension. So it would give us the same result, 1, 4, 34, 48. Another way we could do this, the usual way, which we are familiar with, although I'm sure not all of you remember the ternary operator, but this is where we're going to look at it. You could, for instance, say, let's say for some reason, if it's a positive number, you add that number to the list, but if it's not, then instead of the number, you append none. Let's say for some reason you want to have a none value for each non-positive value in that list. So the result would be like this. You would have 1, none, none, 4, none, 34, 48, none. So you have placeholders for values that you discarded. The question becomes, can this be done using the list comprehension? And the answer is yes, because, well, first let's talk about doing the same with the ternary operator, because the usual way using the ternary operator, and it would look like this. So inside the parentheses, you have a ternary operator. This is what we're talking about. This is the syntax that I wrote in the chat. You have expression if this condition is true, else you have expression if this condition is false. So basically it says add the number if the number is 0, otherwise add none. And this is still the usual way, so this is not a list comprehension. This is just using a ternary operator in regular code. The result would be the same. But now we understand that we can actually use this ternary operator inside the list comprehension. And this is the way it would look like, combining list comprehensions with ternary operators. So Vicky, this is the most interesting part for you. Pay attention. This is what it would look like. So my question now is for all of you. Tell me where in this list comprehension, what is the expression? What is the expression part of the comprehension?
It's like the if number is greater than 0, else none.
Well, the number in front is also part of that expression.
Well, I mean, I call that like the sort of, well, yeah, okay.
So starting with number and ending with none, this is actually the expression.
Yeah.
So what you have to understand that this list comprehension actually doesn't have the conditional part. The conditional part is provided by the ternary operator inside the expression. Because sometimes people get confused and they say, why do you have, if you use if, why do you have the if at the end of the list comprehension? Because remember, if we use it like this, let me return back, sorry, where is it? Here, we have the condition at the end, but then for some reason, if we do, it suddenly moves to the beginning of the list comprehension. And I remember this confusion in my case as well. So suddenly it's here. And the reason is that those are two different things. Here we just have an expression which uses a ternary operator. The list comprehension itself does not employ a condition. Theoretically, you could add a condition at the end, but that would be useless because you would be repeating the condition which is here. So there is no sense to do this. So once again, if you do want to use an if-else clause in your list comprehension, you use a ternary operator in the expression and you forget about the built-in conditional inside the list comprehension itself. You just don't use it. you'd end with the sequence that you're
So,
iterating over.
can I ask you to clarify something? Um,
Yes.
this expression here, okay, versus the one that you have the if number greater than zero as part of the for loop, they would
Yes.
actually yield the same result, right?
You mean this one?
Yeah.
Yeah, it's exactly the same thing. So you're basically
No,
using the
no, no, not
comprehension.
not this one. There's
This
one,
one?
no, there's one where you wrote it as one line, but you had like the four numbers in numbers if like numbers greater than zero.
No, it would be a different result because that one does not give you the none. If you only have the if, you won't be able to get the none.
Okay. Okay. Um, okay. I got that.
Okay.
And then my second question is when you have this statement here, right? Um, like number if number um I forget what was my question. Sorry. I had a question, but I lost it.
It happens
Well,
sometimes.
I have that question too, and I actually had to do an experiment to find out. After you did the filtering, where you have the if number greater than zero,
Yeah.
I thought, oh, could we do the same here if we just move it and omit the else none? Would that still work? If I wrote number if number greater than zero for number in numbers, the answer
And
is no, it's a syntax error.
yes, but why? Do you understand why it's a syntax error?
Because you're doing it's whatever a try something
Ternary.
express ternary
Ternary.
expression. So you
Ternary
need all
operator.
three elements.
Yeah, so if you want to use the ternary operator, it has to be the correct syntax for the ternary operator, which always requires an if and an else. So if you're not using a ternary operator, you can only use the conditional capability of the list comprehension itself. And it has to be, in that case, it has to be at the end of the list comprehension expression.
Oh, sorry. I remember what my question was. Okay.
Shoot.
So, one comment. Dieter, can you send your two versions to me? Um, because I think I know what you were saying, but it would be helpful if I could actually see like what you were talking about.
You mean the wrong version that doesn't run?
Yes. Yes.
Okay.
Okay. Because like I feel like sometimes, you see the run version, it doesn't run, and then if you understand why it doesn't run, it actually helps me to understand it better.
Okay.
Um,
And I
if you
also,
can send me all of your versions, like the ones that you tried, and then the wrong version that doesn't run. Okay. So, Alex, last question. Okay. And so are you saying that if you were to put this conditional, okay, at the end of the for loop, um, I can only use an if statement, but not the else?
if you mean at the end of the list comprehension, you're correct, yes.
Okay. And so if I want to use the if else construction, which is the ternary operator, it would have to go in the beginning where the expression is.
Yes, absolutely correct.
Okay. Got it. Yeah.
You got it. It's important to understand that those are two different ways of solving this problem. So one of them is built into the list comprehension, the other way is actually externally brought into the list comprehension using a ternary operator. This is a very confusing thing for people who see it for the first time and they don't understand why it's in different parts. It's simply because those are two different things. It's not the same thing. Anything else? Any other comments? Let me quickly look. You were asking whether you can use comprehensions to create a nested structure. Yes, you can. It makes the nested comprehension a lot harder to read. So it's not something that I would actively encourage. But yes, you can. And I see that Nick added like an example, but honestly, it does get harder to understand like what's written here. So it's basically one comprehension inside another comprehension, but it's doable. Okay, and I see Dieter sent you the examples. Okay, any other questions, comments, grievances? I don't know. Maybe you're looking at this and you want to cry, and you can share your sorrow with me. I'm willing to lend a shoulder to cry on.
I'm guessing that we use this only as we're like working to simplify or clean up language. I mean, going from a beginner programmer to, trying to level up. I mean, I'm probably still going to have to write it all out and make sure the for loops work and do it um um the
Yeah,
bottom level way, and then you go back and you practice by saying, okay, now if I replace this with the list comprehension or
right.
a ternary operator to make it, to try and level up to
Exactly.
to do it and see if I can do it without breaking the code that was just working.
Right. You're absolutely right. So the thing to remember is that you do not need to employ
Right.
list comprehensions to write code. So they are, once again, syntactic sugar. And once you get used to them, you sort of go, okay, of course I'm going to use them because, it's faster to write.
Right.
But there is a certain learning curve where you have to sort of go like, much like you said, you first write out the usual way, a full complete for loop, and then you go, okay, how would I do the same using list comprehension? And after a certain time, it just starts clicking into place, and the syntax sort of grows on you, and you go, okay, now it's clear. This is the way it works. So don't sweat it.
Yeah. So it's
It's
just practice, practice, practice,
yes,
practice.
exactly. Much like everything in code, it comes with
Everything
practice.
in life is practice, practice, practice.
Yeah, there you go. And the same applies to Lambda functions. You can code without Lambda functions, but there are certain places where you want to actually create a function for that simple situation, and the Lambda saves you the headache. But is it necessary? No, it's not.
Cool.
Let me take another look. Okay, I like the term syntactic sugar, not necessary, but we love it. Exactly. So I think that's why syntactic sugar causes cancer of the semicolon. That's so funny. That's a good one. That's a good one, Nick. Thank you for sharing that. I have not heard that one. That's funny. Okay, so we have about 10 minutes. So maybe let's look at a couple of the assignments that
Sorry, Alex. So I have a question for the
should.
um examples that Dieter gave. I don't understand
Okay.
why his second example gives a syntax error. Because I would have assumed if you could use a ternary operator in the expression portion, why can't you use an if statement?
Because if statements syntactically don't work like that, you cannot insert an if statement inside of a line of code. An if statement always has to be on a separate line followed by a colon.
Yeah, I have a more general comment about that. The idea of the list comprehension is to take some existing sequence and then transform it into a new list. And the if at the end is like a filter. So if you don't want to include all of the elements from your original sequence, you use that filter. That's why it has to be if and not if else, because if you use else, then you're saying, well, sometimes I want this, sometimes I want something else. Whereas it's really a filter where it says only include elements under these circumstances. Okay, so does that first part make sense, Vicky?
Not really.
Okay. Well, let me repeat it more slowly, I guess. The if at the end is just to filter out certain parts. Like let's say you didn't want the negative numbers in your new list at all. You just want to throw them away.
Yeah.
Okay, so if we have like 8 numbers in our first list
Yeah.
and we want to throw away all the negative numbers, we'll end up with a smaller list,
Yeah.
right? And
I think I think what Vicky is actually
I
asking
know
is
I was
why.
like, I was getting to there slowly. So the if else in the expression is when you want your new list to be the same size as the original list. So you want to make a decision, but you want to do like a different decision in each case, but you'll still have like the same number of elements. So that's why that one has to be if else. If you only have an if, then it's not going to, what's going to happen when it's not true.
Well, I mean, you just filter out those conditions that are not true or those numbers that are not true.
Yeah, but the way an expression works is it always produces one value. That's what an expression means. So if else, the ternary is an expression because it always gives you something back. Whereas an if on its
However,
own,
if we're writing regular Python code, right? If I write it on separate lines, I could have like, if this, okay, do this. If this, do this. I don't always need an else. I mean, it may not be in terms of like style, the best style, but my program doesn't crash if I just have like a whole list of like if statement with no else to match it.
yeah, well, list comprehensions are very specific. They're only made for one thing. Like regular if and for loops and stuff, they're very general purpose. List comprehensions have only one purpose, which is take some data, transform it into a new list. So they're very restricted. And when Alex showed the general form, that's why it said expression, for loop variable in sequence if something. It has to be an expression because that's the syntax of it.
But that still doesn't answer my question why an if statement doesn't work in the expression part, whereas an if else would work.
Because if else is a ternary operator, which is it's a, for lack of a better word, it's a finished statement. It's a finished expression. While an if only a piece of code, you can't simply insert an if condition.
Okay. Okay.
Like in code, an if condition always has to be followed by what happens with that if condition.
Okay. I don't quite get it, but it's okay for the sake of time.
Okay. Yeah, I mean, if you use just an if statement, you could do all sorts of things. You could say like if x is greater than 0, print something, right?
Yeah.
You can't like print in a list comprehension. So they don't allow general if statements because then you would be able to do all sorts of stuff that doesn't make sense in a list comprehension. All you have to do is like return some value that you want to put in your list. That's the only thing you can do.
I don't think we actually have that much time because it's already 57 minutes. So it's not like we're going to now go through a number of assignments on list comprehensions. So I would rather, if there are any more questions remaining for this specific topic, I would rather answer them now and maybe go through some examples or whatever.
You can
So,
always go to office hours. And then for the list comprehension exercises, well, Dave Nguyen did provide solutions for some of the harder ones.
yeah, you just have to double click on them so that because it's white on white, you have to select them to see the solutions. But I think they are a bit limited in terms of what you have to do inside the list comprehension. It's all about slicing strings, I believe. It's not a great variety of exercise types, but it's helpful to understand the general syntax of
Well,
how.
considering CS 106A didn't really talk about list comprehensions,
Sure.
it didn't have a good source of problems. So So I figured that was better than having nothing at all.
The birds. Well, we could do something quickly. Let me check. I'll have to. Oh yeah, let me stop sharing. I'll have to find the link first. Just give me a second. I'll open Vicky's file. I'll copy the link. I will open it. Which one is the birds? Birds. Alligator. No, that's not a bird. Okay, so the one with the pelican, wagtail, peacock, toucan, and ostrich and goose, I suppose. So let me copy this and let me share my screen again. Okay, so I guess it's this one. We have a list of bird names, and let me copy the expected output. Of course, you first have to understand how it comes to this output. So basically, what it does, it looks, it goes back and forth the last four letters and the first three letters, and then it's the four last letters, and then it's the first three letters, and then it's once again the last four letters and the first three letters. So the question is, how do we do this? And I would actually ask you to think about this. So let's say we're creating a new list using list comprehension. Let's call it, I don't know, bird letters. I have no idea what to call it. And then we're going to print it. And printing it, we should get the result below. So how do we print this? Can someone help me out? Do you have any thoughts on how would we write the list comprehension in order to get from here to here? So remember, we need expression for variable in sequence, and we can have an optional if condition, but we don't have to do it. So can anyone help me with any part of this? Maybe pick the easiest one first and we'll fill it in.
Well, I mean, you will need a loop, and so I would probably start by writing the loop. Just say like for bird and birds, okay. And then it
Okay,
looks
so let's
like
do that. We can exchange variable for bird. We can change sequence for birds because that's the list that we're working with.
and then it looks like you are truncating based on the position of your birds.
Yes.
And so if the positional indice is odd, okay, you want to retain the last four letters. And so you would want to slice um, well, I mean, I would have to like look up how to write the syntax because I just don't really remember the syntax. But the idea is like um, birds is a list, okay? And so if the indices is odd, you want to truncate from position 0 through 2, and then returns the rest. And then if the position is even, you want to basically truncate from 3 all the way until the end. and
Okay,
then retain that beginning portion.
okay. But how do we actually do this? If you're saying we are doing a for loop, like for birds and for bird and birds, how do we get access to the indices that you're talking about?
So birds is a list, and so you could just um um uh you could use like birds bracket, right? Like the bracket would be your indices, and then it would be like X or something like that, right?
You mean when we actually do the truncating?
No, like
I think Vicky is referring to how do we um, find the third bird once we know it's the third bird. It's
Yeah,
bird
sure. No,
of
I
the.
understand. It's correct. I mean, we need to understand whether it's an odd bird or an even bird. But the question is, how can we do this if we are iterating over the actual values? Because right now we have for bird and birds, we do not have access to the actual indices.
Before
Oh,
we go
oh,
there, can we
oh,
get rid of the if
you could
condition?
write a different kind of loop, right? I mean, you
Of
could do
course.
like a for I in range loop, which means instead of looping over the elements, using looping over the indices. Yes.
Right.
I
So then
taught
that would
this
be
in this section.
for,
I
for,
just
for I in
that's
range.
not what you were
What's the
talking.
range? What's the range
Um,
value?
for I in range, it would be len birds.
There you go. So now we have access to the indices. So
You just need
now
to ask your question in a more specific way, because I
right
feel like,
to it make it a bit easier. I understand. So now the question is, do we actually need this condition here?
of course, you need the condition. If you don't have the condition, how do
Okay.
you tell if it's an even or odd bird?
Remember,
Okay.
this
So
is a filtering condition. It
Yes.
eliminates it.
hold on. Let's try it. Let's try it
Wait,
first. So
Peter,
basically,
this is what I was telling you, right? Like I feel like, I'm just like being put on the spot with this like Socratic method. I don't really know what he's asking.
You can let someone else answer if you want.
This is
We'll see
like,
if
huh?
anyone else is brave. We can see if anyone else is brave enough to answer.
What the question is like I need to go to work very soon, so I can't like keep the Zoom um running
but this
too.
is the last thing we're gonna do. So well,
Well,
let's try it if we have the condition. So what would the condition be?
I mean, the condition would be like if I okay, like suppose if I is divisible by 2 and then it returns like a modulus of 0 and then that's an even bird.
Yeah. So
Okay.
that's like pelican, peacock, etc.
Right. If that's an even bird, I think you want to drop the first 3 letters. And so,
I think you need to take the last four, so it could be different lengths. So it's basically about taking the last four.
okay. Okay, if it takes the last 4, it would be something like colon 3 or something like that.
Well, first you
You,
need the bird. Wait,
Oh, yeah, 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 bird, bird, bird.
it's bird of I.
but then we don't have bird. Remember, we don't have bird anymore. So how
Oh,
do
Birds
we?
of
you
I.
could do the value like birds, colon I.
Well, not column,
Bracket.
but square brackets,
Yeah, that you know what I'm talking about, right? Like, it's like
Yeah, so
and
this would
then
actually run if we ran it. Okay,
this would run, but it would give you
well, it will
just
give
a
you
list.
the
it
whole
gives you
It,
half the birds.
yes.
so, and basically, in order to keep
Oh,
the
okay, okay,
last
okay.
four
Okay,
letters,
okay.
you
I
did
changed
it
my
like
mind.
this.
Alex, I changed my mind. Okay, we need a ternary operator here, because we need an else. And so you cannot have that if at the end of your
There we go.
statement. Okay, you have to put it
There
in
we
the
go.
beginning. Otherwise, okay. Okay, and so birds eye, and so I guess like if um I don't know how to write this. Like basically if I is divisible by 2 and gives you like 0, okay, that's an even bird. Oh, no, no, no. You want it to be not 0 first, okay?
Doesn't
Um,
matter.
right. But we're starting with like a not even bird. Okay. Okay. And then you want the last 4 letters. And so
No, we're actually starting with an even because we're starting with 0.
oh, 0 is counted as even. Okay.
0 is even.
Okay. And so if that is even, then you want to take anything after the third position in that word.
Once again, it's not everything after the third position, it's the last 4. So you have to take everything starting with the fourth to last position. Because instead, if I have something like this,
Uh-huh.
you would not get the correct response.
Oh, okay.
All of
Okay.
this. So in our case, it's starting from the minus fourth index, which is 1, minus 1, minus 2, minus
Well,
3,
I
minus
mean,
4.
I think your examples is just not clear because all of the birds that you gave, okay, looks like it's
Right. At the moment, they're
okay.
all 7 letters, but you can't
Correct.
be.
Okay. And so I didn't know that, but okay. Um, anyways, yeah.
So let's think. What do we write here?
If okay, if I is equal to 0, and then I think well, else. Okay. Else um you want the first 3. And so that would be like 0 to 2 or something.
No, you don't need the 0, but remember that this is not included.
Yeah, okay. That
So it would have to be 3. But before that, obviously, we need to write birds, and here
bird.
I have to write I.
Yep.
Okay, let's see. Looks good, looks legit. Yay! All right, good stuff, good stuff. I think we're done for today. So thank you very much, everyone. Thank you to have been more active in discussing this. It's always good to have someone to talk to and to have someone ask questions, even if some questions have been previously answered by Dieter and Nick. So this is it for today. Depending on where you are, have a good morning, day, evening, or late night. And I believe we will meet again in about a week and a half. It's going to be Monday, like not next Friday, but the Monday after next Friday. And we're going to be talking about the search engine, which is called Bajillion instead of Google. And yeah, that's it for today. So thanks a lot, and see you next time. And don't forget to visit office hours.
Mhm.
Emma, Dieter are always there waiting for you.